If there is too much load on a single entity, things start breaking up. That is the law of nature, and same law applies for computer systems as well. So in this video, we are going to talk everything related to them, that what are load balancers, why do we need that, and what are the load balancing techniques available to us. So without any delay, let's get started. So load balancing is the method of distributing network traffic equally across the pool of resources that support an application. We know that modern applications must process millions of users simultaneously and return correct text, videos, images, or any other type of data that user is requesting in a fast and reliable manner. To handle such high volumes of traffic, most applications have many resources with duplicated data between them, and a load balancer is placed before that can distribute the incoming traffic equally to all of those resources behind the scenes. Number one benefit of load balancing is it helps with the availability of the system, because you have multiple servers up and running in the behind the scenes. Let's say that if one of the server goes down or it crashes, still load balancer can pretty quickly define that which other servers are up and running and start routing or diverting traffic towards them, which means even if an unexpected system failure happens, still you will have your resilient systems up in place that will make your system more available. Next, it helps with scalability. So if the number of users grow, basically in the behind the scenes, you need to increase the number of resources that you currently have. And for that, you need efficient load routing mechanism. You don't want to be in a position where you have 10 servers running, but only 5 are receiving load continuously. That is a very bad load distribution mechanism. So that's why if done correctly, load balancing can help greatly with the scalability. And it is also true that without load balancing, you can never achieve scalability. That is also a given fact. And next thing is, if you have availability and scalability, automatically your performance goes up. So performance is heavily dependent on appropriate, smart, efficient load distribution. So now let's see that what are the different load distribution techniques available to us. So mainly load balancing can be distributed in two portions. First techniques are static techniques and second one are dynamic techniques. So first let's start talking about static techniques that are available to us. So number one static technique is simply round robin technique. Okay, so let's assume that this is our system where we have a bunch of different users trying to calling our systems, and our answers or our system is currently running in these servers. We have a load balancer placed in between that is going to take care of load distribution. Now round robin, as the name suggests, it's quite simple. Basically, load balancer would keep on sending sequentially requests to all the available server. So first request will go to the server number 1, second will go to server number 2, third will go to server number 3, and fourth will go to server number 4. Now the moment fifth request comes in, it will once again go back to the server number 1, and in the round sequential fashion, the load will start getting distributed. So if for some example, if one of the server gets crashed out or it is no longer there, then the load would be equally distributed amongst the remaining 3 servers in the round robin fashion. And this is the first technique. So next load balancing mechanism is called weighted round robin. Now this is very similar to round robin approach, where all the incoming transactions are going to be routed one by one to all the available servers. But from time to time, it could be possible that there are going to be some additional incoming requests that contains heavy weight or that are more in terms of priority. So whenever these weighted requests comes in, we could have a load balancing policy where we are going to treat them differently. Maybe we send them to a separate server that is specifically more power to handle these kinds of priority requests. Or it could be possible that amongst available servers, we have 2 servers that are more powerful than the rest of one. So whenever these special request comes in, we are going to send them only to those servers. So basically, weighted round robin is a very similar approach to the round robin scenario, but the only difference is now we are also considering the actual priority of incoming traffic as well. Now next load balancing method is IP hash method. This is very similar to round robin, but the only difference is that all the incoming traffic, this load balancer is going to do some mathematical computation to those incoming IP addresses, and based on those mathematical computation, it is going to assign it to either one of these servers. So this mathematical computation is typically going to be like normal probabilistic determination kind of mechanism. So let's assume that it states that all the incoming traffic, it is going to do modulo by 3, and whatever the remainder is going to be, it is going to route to that particular server. And currently we have servers marked as 1, 2, 3 value. So logically each server should get 33% of the incoming traffic because of this mathematical computation, because that is like a logical reasoning to understand. And if we add the number of servers, we would still have more servers, so we can point them in terms of this. We would start doing modulo by 4, so each will start receiving 25% of traffic. So this is just a different way of basically round robin, but we are going to use some hash function on the incoming traffic, and that computation is going to be done by load balancer. Now this concludes all of the static mechanisms we have. Now we are going to see that what are the dynamic load balancing mechanisms available to us. And the first one is the least connection method. So least connection method, as the name suggests, we are going to check that which particular server behind the scenes has the least number of active connections. So let's assume that this is our load balancer, and these are currently 3 different servers that are up and running. Now we know that from the previous traffic, there is going to be incoming traffic already directed towards each of the server, and it could be possible that some of the servers, they are already done with all the computation. Meanwhile, some of the servers, they are still processing previous execution. So in this case, we will not go for round robin or something like that approach, where we strictly go one by one in each fashion. But in this scenario, we are going to see that, okay, load balancer is going to have some client up and running on each one of these servers, and that server is going to continuously let the load balancer know that, okay, hey, currently this particular server number 1 has 5 active connections. Now this server number 2 has 2 active connections, and the server number 3 has 4 active connections. So in this case, whenever a new request comes in, load balancer is going to see that which server has the least active connection, and because server number 2 has the least active connection, dynamically it is going to route traffic to the server number 2. So this yields a higher efficiency in terms of server computation, because every single time we are only pointing traffic to the server that currently has the least active connection, so we can complete those transactions in the fastest manner. So this is one of the first dynamic load balancing technique. Second is very similar, that is weighted least load balancing. And whenever weighted least connection method comes in, it's going to be pretty much same, that load balancer is going to keep track of all the active connections that are currently being placed. But when we do get some special incoming traffic that has more weight, in this scenario, it is going to, on top of sending to the least available server, it is going to send it to the most powerful and least available. So let's assume that in this case, this one is more powerful server, specifically designed for weighted traffic, and it also has moderately less traffic. So in this case, rather than sending this transaction over here, the load balancer is going to send it over here so that it can get processed faster because it contains higher weight. So this is going to be the weighted least connection method. Now next one is least response time method. Now what least response time method means, the name is quite understandable, that we are going to keep track of what are the response time for each one of the servers that are currently available. And once again, we are going to have an agent running in each one of the servers that is going to keep track of the average time computation in order to complete any particular task. So let's say that currently we already have all of these transactions coming in. So this load balancer knows that this is completing the transaction in 100 millisecond, this is going to complete in 200 millisecond, and this is going to complete in 500 milliseconds. So in this case, whenever a new transaction comes in, because this is completing in the least response time, then we are going to route this transaction for this particular server, and then we are going to increment the time by that particular minute until the transaction has been completed. So this is also one of the popular dynamic routing mechanism. Situation where latency is very critical, you can go for this type of load balancing mechanism. And the last load balancing technique is resource based. So what is a resource based mechanism means, that we are going to check that which server has the most number of resources available. And resources can be anything: connection to the data point, or response time, or the amount of memory, or the computation power. Either scenario, we will have option to choose from all of these metrics. Let's assume that we are currently judging based on the CPU power. Okay, so this is our load balancer, and load balancer know that currently what is the CPU usage for every single server. So let's say this one has 78% usage, this one is 70%, and this one is 55%. So whenever a new request comes in, because this one has the highest resources available, then the new traffic is going to be routed over here, and then again it is going to do computation for the next incoming traffic, and maybe it can be go to some other place. Now there are actually two types of load balancers, and they have to do with the OSI model. Number one type of load balancer is actually called layer 4 load balancer or transport layer load balancer. This type of load balancer typically works with TCP, UDP or IP based routing. So depending on the incoming traffic, it simply routes the traffic back to the backend servers, nothing more than that. And it is tend to be pretty quick and efficient, but it does not care about who the user is, what is the address, what is the SSL token, or what things like that. It is tend to be there only to route traffic to the appropriate backend servers. So that is why it is called a transport layer load balancer. And second type of load balancer is actually layer 7 load balancer, that is called application layer load balancer. Now this is little bit more smarter load balancer because it takes care of HTTP or HTTPS request, incoming parameters, what are the attributes the incoming request has, and depending on those it can actually provide security and also efficient routing based on the incoming request. So all the weighted load balancing techniques you saw, they can pretty much obtained using the layer 7 load balancers. So they tend to be slower in practice, but needless to say they are much smarter. So the question comes that which load balancer to use. Should we use layer 4 load balancer or layer 7? Well, actually both. So whenever the incoming users are coming in for the first time in your system, or whenever you are dealing with the outside network traffic, you want to use a layer 7 load balancer. But once you are in the internal system and you just want to route the traffic, you have already verified that the incoming transaction is correct. In that case, you want to operate on the layer 4 load balancers. So if you say this type of answer in your interview, your interviewer is going to be blushing because they found the perfect candidate, and it is a really important insight to have. So these are the two main ones that you need to worry about. And now there are actually a lot of load balancing solutions available in the market. Some of the popular ones are NGIX and Amazon Elastic Load Balancer, Microsoft Azure Load Balancer, Google Cloud Load Balancer, and bunch of other more. So if you do a quick Google search, you can find about all of them. And the purpose of this video was to give you familiarity with the concept of load balancing. I know it's a very simple concept, but it's also a very important concept as well. So I hope you found this video useful. Let me know in the comments if there is anything else I could have done to improve this video, and see you next time.